Okay, all right. We'll go ahead and get started. So yes, if you're watching the video, make sure you sign up. You sign up. You and your group signs up for a time slot to do your proposal meeting. Okay, the proposal meeting's on Zoom, and it will take place next week during week 6. So make sure you are taking time this week to meet with your group, to identify some candidate data sets and things like that, okay? And I will be using this proposal meeting grading rubric, okay? There's a question, do you need to kind of specify, produce anything, like produce a report or anything like that? That is not required, but if you are able to show that you've done the initial exploration and analysis, right? So if you want to just say, okay, here is the kind of histogram we produced for this variable, and you'll notice these are the outliers, and we've investigated them, and based on our investigation, we're gonna go ahead and remove these outliers, or we think we can include them, or I have no idea what these outliers are. Okay, I have no idea what these outliers are. Probably not the best answer. But yes, I will be using the proposal grading rubric. So I hope nothing will be a huge surprise for you regarding your grades for the proposal meeting. Okay, so the proposal meeting is graded. I'll kind of give you some feedback at the end. I've scheduled the meetings to be 20 minutes, and probably most of us will finish most of the groups, I hope, will finish within 20 minutes. Usually, if everything looks good, we'll be done. If I have some concerns, then I might ask a whole bunch of questions, and the meeting can spill longer than 20 minutes. I've given kind of a little bit of cushion for each group to go up to, I guess, 29 minutes or 30 minutes. And then, in some cases, we need even more time, and I'll have to kind of schedule a follow-up meeting there. But usually, if your group has kind of done the homework in terms of being prepared and showing that you have explored the data, you are able to explain the data, then I kind of just go down the list and make sure all of my concerns are addressed. So yeah, there's lots of data out there. You just have to kind of go looking for it, and you just have to kind of ask questions whenever you look at the data. I want you to go in with just a tiny bit of kind of I don't know about tiny bit, just with enough curiosity where you're gonna kind of try to get down to, where did this number come from? That's what I want, rather than just kind of accepting these as like, oh, I believe these numbers 100%, right? Okay, I guess any questions about what's expected before the proposal meetings start next week? No, we're good. Okay, all right. And yeah, the proposal meetings are on Zoom. I use the same office hours link, so just log in there. Yeah, question?
Yeah, I feel like this is a stupid question, but does the whole team have to be there? If someone can't make that?
If someone can't make it, that's fine. I would say at least three people should be there. Okay. So, okay, today's lecture, I'm going to cover conditions and loops in R, just in case, there might be a time where you need to run like a short script or something to conduct some of this. I would say this is tangential, or at least adjacent to chapter 7 in the textbook. So modern data science with R, chapter 7 is titled iteration, and I've assigned a few exercises. Oh, so by the way, I've posted homework 3, and
data camp associated with that?
I haven't posted data camp.
I'm not gonna appreciate it.
Yeah, and then homework 3 is up, okay? And I've assigned a few questions from chapter 6, which is on tidy data, a few questions from chapter 7, which is on iteration, and a few questions on from chapter 8, which is on ethics, and we'll have a lecture on ethics as well. But anyway, if you try to read through chapter 7 right now, I think there's some stuff that we just haven't covered yet, regarding like programming flow and stuff. And this is all stuff that gets covered in Stats 20 and Stats 102A. Kind of, if you've taken any kind of programming course, you're familiar with if and else statements and loops and things like that. But then again, this class doesn't assume any kind of prerequisites regarding that. So this lecture is for, if you've never created a for loop, if you've never created a while loop, if you've never done if and else type of coding, or even if you have, it could be useful to kind of see here. When you read chapter 7, there's kind of, they just start assuming that you've created a for loop and things like that. So I'm actually kind of using some, these are slides from another class I teach, 102A. And I'm going to kind of cycle through these things. Some of these examples might be a little bit more complicated than they need to be, and maybe I'll just kind of note some of these things here. Okay, so everything, the if statement, I shouldn't say everything, but if statements for and while loops use conditional operators, basically true and false statements. Okay, so it's like, if this is true, then do this, and if it's not true, then you'll do the else part. Okay, and so in R, basically we write true with all caps true and false with all caps false. This is different from other programming languages, like notably Python uses a capital T and lowercase RUE. For R, it's all caps true, all caps false, and if you take one of those things and you do like a mathematical operation, like a plus, it will convert them to different values. So false will become 0, and 0 becomes false, but then basically any other number becomes true. So here I've got the vertical line for the OR operator. So that's basically true or false, and in that case it becomes true. And operator basically is the ampersand, and that is the true, and true returns true, and basically any other combination returns false. The exclamation point is for not, and then you have also exclusive OR, and that means one has to be true and one has to be false for the exclusive OR to return true. And if both are true or both are false, it's going to return false. Okay, these are vectorized, so let me just kind of show you an example. I guess on the next slide. You also have what's known as the non-vector OR and the non-vector AND. You use these inside like an if statement. In an if statement, you can only have one value that's either true or false. You can't give an if statement multiple true value, like a true, false, true, or something like that. Okay, you can only do if this is true, then do this, or if it's false, then do this. If you give it if true, false, true, it doesn't know what to do, and it's going to error out. So
could you do true?
No. Oh well, so you have to do if true and true, okay, and the double and or the double or will take these values and only return 1. So like if x is true, false, true, the double or will only use the first value.
Use a true one?
Yeah, the very first value in that kind of listing of things. So if you have if it goes false, false, true, or something like that, it only looks at the very first value, the false.
Oh, okay.
Okay, so it only so the double and the double or these are the non-vectorized ones, kind of make sure that what gets returned is only a single true or false value, rather than over here, you can have kind of a vector true, true, false, and then a false, true, false, and it will do like the first values or this and this. And so look at here. Here we go. These are the examples, okay? So X is true, true, false, false. Y is false, true, false, true. The single or operator goes, okay, let's compare them. We call this bitwise comparison. So we go true or false, that's going to be true. True or true, that's true. False or false is false, and false or true returns true. So basically, when you have an or operator, if any one of these things, if either one is true, then it's going to return true. The only combination that returns false is false, false. Okay. With the and operator, basically, if anything is a false, it's going to return false, and the only thing that returns true is true and true. So here is the and operator, X and Y. True and false returns false. True and true returns true. False and false returns false. False and true returns false. Okay. The double or only looks at the first value and it returns true. The double and only looks at the first value and it will return false. And you get this warning. Okay. It says, you gave me a bunch. Are you sure you wanted to do that? Yeah.
Could you do like the Z value? Yeah.
So like X or Y or Z?
Yeah.
Yeah, you can do that. And it will basically kind of do like the X or Y first, and it will return this. And now you have a true, false, true, true, false, true, or, and now you
that to compare with Z.
Compare that to Z. It reads it left to right type of thing. Yeah. Yes.
If you had a mismatch, so for example, if you had Y, it was only length 2, so that false true, would it repeat through it again?
Yeah, so R does what's known as recycling, and if you have a shorter thing, it will recycle it. Okay, so if you have missing values, what is true or NA? True or unknown? What's that going to return? This will return true because it doesn't matter if this thing was true or false. If you have an or, that's going to be this. The true and NA though, it's going to return unknown. It's going to return NA because it depends. If this is true, if the NA turns out to be true, then the response would be true. If the NA turned out to be false, the response would turn out to be false. So it really depends on whatever the NA is. So this is going to return NA. False or NA will return NA, and the false and NA will always be false. Doesn't matter what's inside the NA. Okay, so all of those answers, true or NA, true and NA, true or NA is true, false and NA is false, but then these ones are ambiguous.
What do you mean by the NAs? Like it could be true or false?
The NA means unknown value, missing value. So it's kind of like, you could say marital status, right? Married, true or false, right? So if somebody's married, you'd say true, and if the person is not married, you'd say false, and you'd say, okay, what about this person? Oh, I don't know, right? And you just write down NA until you find out that information. Right? Yes.
Would you say it's like treated the same as like null or none?
So null or none is different. Null or none means the thing doesn't exist. So for example, another example would be someone's age is, if you don't know it, it's missing. Okay, and so that would be NA. So if you don't know the person's age, you would say NA. Okay. What if we wanted to kind of keep track of their pets and their pet's age? Okay. So some people have a pet, and you may or may not know the pet's age. So you'd say, okay, Joe's dog is 3 years old. Okay. Okay. Sally's dog, I don't know. That's missing. Okay. Greg has no dog. That would be a null. Okay. So if it doesn't exist, you use the null. If it exists, but you don't know what it is, then you use the NA or the missing. And so that's kind of the distinction. So if you know it, if you know it does not exist, you would put in the null. If you know it exists but you don't know what it is, you use the NA. All right, so here are just kind of some more things with NAs. Now I have exclusive or, true or false returns true, true or true exclusive or true returns false, false exclusive or false returns false, and then false true returns true. And then any combination with the NAs all return NAs because the exclusive or return requires all of these things. You have these kind of generalized things that, so if you want to do like multiple things, instead of doing like X or Y or Z or something like that, I would probably just say the any or the all, okay? So here, U is true, true, true. Any is, are any of the values true? And that will return true. Are all the values true? That is also true, okay? V is true, true, false. Are any of the values true? Yes, true. Are all the values true? That's a false, okay? And here I have false, false, false. Are any of the values true? No, that's a false. Are all the values true? No, that's also false. So that's any or all. Okay, maybe this is a little bit too nitty-gritty technical here. I won't. So I wrote, if you add a zero length vector, basically a null, to a vector of logical values, I wrote it should not affect the result of any or all. So if I said any, logical zero basically is a non-existing value. You know, let's skip this, okay? Just when you take 102A with me, I'll put this slide in. I'll test you. I'll test you on that, okay? But okay, so skip. Here, what do I do?
What's
here?
102A?
102A is, I forget the title of the course. It's like statistical computing with R or something like that. It's basically like you have stats 20, which is your intro to R, and then 102A is your, like your intermediate to R.
And then you have Python, what, 21?
Intro to computational statistics.
Intro to computational statistics. So we do, you know, we do stuff like Bootstrap and I don't know, randomization tests and stuff too.
What kind of prereqs? Or I guess all
You have to
that.
take stats 20 before 102A.
Not 33A.
This
Yeah.
class wouldn't be enough.
This
wouldn't be enough.
would not be enough, no.
Oh.
You need stats 20 is like a full programming course. Okay, but anyway, so 10, 11, 12, skip, okay? 10, 11, 12, skip. Maybe I'll give you I'll annotate these things and say, skip, okay. How do I do that? Yeah, question?
I guess this question is relating to the final exam. Is there gonna be, are you gonna give us some sort of study guide? Because what if we forget that we should skip this part? We like study it.
Okay, so not a final exam. It's just an exam that happens to be on week 8, okay? All right, so it is the one exam we have in the class, but it's not a final. It's a distinct designation the university gives to something. Okay, that one I would say the exam will focus more on things like ggplot and dplyr and kind of manipulating your data. So I'll give you like a data set and I'll say, hey, make this graph. Or, hey, I want you to find summary values for these groups. I want you to create a new column and stuff. So I'll give you a study guide, but
So it wouldn't be open note, it sounds like.
no, it's open note because it's you're taking it home, right? It's
Okay.
it's the exam. So the exam is done online at home. I'll talk about this, okay?
Yeah.
It will be proctored via Zoom. So everybody has to log in via Zoom, and it's synchronous. So it's not an asynchronous take-home exam. So some places are like, you take this home and you have 24 hours to do it. This is going to be, we start at 9, we end at 10:50, or you know, it's I give you just a little under 2 hours to do it, and it's going to be that block of time. You take it during that block of
I
time.
thought people with CAE accommodation, do they just stay on the Zoom?
Yeah, we'll make arrangements for that. Okay, so but basically you log in on Zoom. You take it on your computer while you're logged in on Zoom during that kind of designated time. It's open note. Just no no throwing parties and taking the exam together. So
Oh, no party.
yeah, no exam parties. Okay,
Gotcha.
that's that was something that I was made aware of that happens. So
Exam parties?
yeah, I don't think a bunch of students were doing it, but it did exist.
Of course.
That-
Naturally, like take home exams you want from groups. But
Yeah, so I don't want that. I want to test each individual's person's abilities and not like, is one person in their group capable? That's what the group project's for. But really, the group project, we don't want the group project. Ideally, everybody contributes. Okay, and I'll ask during the final thing. I'll say, what was your contribution? Okay.
I cheer the team up.
Okay.
Moral support.
I do recommend if you haven't done so, you should designate someone in your group to be the leader. Okay. And I know nobody wants to be the leader. Well, I don't know. Maybe some people are like, I want to be a leader because they have control issues or something. But you should designate someone to be the leader that
Take responsibility.
well,
Accountability.
that kind of I don't know, I guess we should give this person some authority in terms of like this person says, okay, if you're gonna, everybody works on this thing, and when we meet back at this time, you need to have this ready so that we can move on as a group together. And if somebody's consistently failing to do that, then let me know, and
Capital.
I can I can come in and intervene. Okay.
So you-
Okay. These are, if you have X and Y, you put in like basically numeric values. All right. And when you do these comparisons, you're going to get true or false values. So is X equal to Y? Is X not equal to Y? Is X less than Y, or X greater than Y? So you think of a couple numbers, 2 and 5, 7 and 10, whatever, and these things will return true or false. And you can do comparisons with strings. I don't know if it's the wisest idea. Less than or greater than is basically, does it come before the other in the alphabet? So words that start with A will always be less than words that start with B. And if you go by that rule, then basically the numbers come before the letters. And in that case, numbers or strings that start with a 1 come before strings that start with a 2. So you get weird things like the string that looks like 10, but it's really string 10 comes before the string 2. Even though numerically, 10 is greater than 2, right? So 10 less than 2, the actual numbers, this is going to be false. But as far as strings go, because it treats them as if it was like characters,
It just looks like the first character. Yes.
yeah, like alphabetical order, right? So if you had to compare apple versus, B, B-E, apple will always come first, right? Any word that starts with A, even if it's 100 characters long, is going to come before in the alphabet before any word that starts with B, the letter B. That's basically what's going on. Okay, there's a whole bunch of kind of functions here that just says is a value a certain type. Okay, and so what could be useful is like, is a value missing? Okay, so you can't. So one thing you can't do is you can't do x equal NA, right? So when you do like a filter or something, you can't say is it equal to missing, because it's that answer is always going to be missing, because you have to think, here's a box that represents missing. Inside this box is something that you don't know, and basically you're asking, okay, here's the number 3, is it equal to what's in this box? Okay, and if you say is it equal to missing, then the answer is always going to be I don't know, because I don't know what's in the box, right? So even if you say, oh, here's a missing value, NA, is it equal to this missing value? And the answer there is also I don't know, because I don't know what's in this box. So you just have to ask a question: is it missing? Is it a missing box? And then you can answer yes or no. So that's so always do that. There's a few, all of these. It's too much stuff, but probably is.na is going to be the most important of these is functions. Okay. the actually this has been updated. Conditions of length greater than 1 will result in an error. Conditions, so if you have an if statement and you have a missing value, you're going to get an error. If you have an if statement and the value inside the if statement doesn't exist, you'll get an error. And if the value inside your if statement is longer than 1, you'll also get an error. So here we can say x is 1 or 3, and is 1 a value in x? That's true. And we can say if 1 is a value in x, which is true, this will print out hello, and that works out. Okay, so the if statement is you write if, parentheses, whatever thing evaluates to either a true or a false, and then you have curly braces. Okay, I'm going to forget. View quiz. Today's first letter is B. Good job. Okay.
Hey, why don't you
I studied for this.
All right. So the first letter today is B. B as in bear is your first view quiz answer. B. Okay. So here I have x is 1 or 3. X greater than or equal to 2. I get a false true. False true. Okay. And here we write if x is greater than or equal to 2, I get an error. Okay? Because here, when you ask is x greater than or equal to 2, we get a false and a true, right? So actually, we just get an error because the length of the logical vector is greater than 1. I need to clean this up a little bit. Okay. Again, here actually, I need to fix this. This says warning, but here again, we have true and false. And anytime you give it an if statement with more than one true or false value, it results in an error. Okay. So if you want to deal with something, you can say, are any of the values greater than 2? That's true, and then that will execute. All right, if you have a missing value, okay, so x5, so if you try to ask what is the fifth value, x is the value is 1, 2, 3, and if you say what's the fifth value in x, it tells you I don't know. Okay, x5 is a missing value, right? And so if you say if is the missing value greater than or equal to 2, we get this error that says missing value where true false needed. So it's saying this thing is evaluating to an NA. It's a missing value. Okay, here is this, if I say which value in x is equal to 4, it tells me that doesn't exist. I get an integer 0. So the which function will, like if you say which is equal to 1, it would say the first value, right? If you have like a whole bunch of things, you could say which value, which of x is, greater than 6, and it'll give you basically a vector of indexes, of positions of which values in x, fit that condition, okay? So in this case, none of the values are equal to 4, so this is an integer 0, and I ask, if is the fourth position equal to 0 or equal to 4 or something like that, and here it says argument is of length 0. Basically, we have a length 0. Integer 0 means it's expecting integer values, but we have 0 of them. That's what integer 0 means. So it says I'm expecting the output should be integers, but I have no integers to report. So that's an integer 0. Okay, we can have these kind of nested conditionals with if and else, and basically we can ask this first condition, if x is less than 0, then do that. If not, okay, otherwise test if x is greater than 0, and in that case print positive, and if that's not the case, then just print 0. Okay, so this exhausts all of our things here. And so I plug in 3, it skips this part, and then it evaluates the second condition here, and it prints out positive. Okay, here is if I test it out with 0, it's going to print. It skips this because this is false, and checks this condition. That's also false. So it says, okay, well then this was false and that was false, so we're going to execute this last thing. So the else conditions only execute if the previous function evaluated false. So here I have if x is equal to 3, and I say if x is greater than 0, print positive, and it sees this is true and it prints this, and once it executes something here, it's going to skip all of these else statements. Okay, so this thing will never ever get executed because there's never a situation where x is greater than 1 but x greater than 0 is false. Okay, so it's only going to look at this only when this first statement is false. So bigger than 1 will never happen. Okay. The sometimes you just want to be able to kind of like assign a value, and so you can say, you know, if x is equal to 5, then assign yes to n, and if it's not, assign no to n. You can simplify that into an if-else statement, and you can say basically if this is true, then assign this value, and if it's not, assign this value. And one thing is that that was a big squeak, is that this is what we call vectorized. So in all of these other cases, if you have like a list of values in x is 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if I tried to plug that in here, I'm going to, it's going to error out, because it's going to, if x is, you know, a vector of 10 values, and we say, is it equal to 5, that's going to return a vector of 10 true false values. It's going to say false. 1 is not equal to 5, 2 is not equal to 5, 3 is not equal to 5, 4 is not equal to 5, 5 is equal to 5, that one will be true, 6 not equal to 5, so we're going to get like false, 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 true, false, 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 and you can't have a whole bunch of true false statements in an if thing, okay? But you can do if else, and it will return an entire vector of these things. So, let me kind of just show you a couple examples with, say, a few loops here, and we can use if else to kind of simplify some of these things. So here is a loop called the for loop, and basically you have some kind of vector, and the for loop will do the same operation for every value in the vector. So 1 colon 10 is going to be the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we say for each value, for each x in that vector, so I'm just picking some arbitrary letter to call each value in there. I could have called it for value or whatever. Then what I want to do is I want to report x squared. And I'm using this function cat, which just says, you know, concatenate all of these results together. Separate them with a space, okay? So we're going to do 1 squared, and then it goes to the next. X is 2, we get 2 squared, 3 squared, 4 squared, 5 squared. And it iterates through every value in that vector until we get to 10 squared. Yeah?
What was the function of like this? I know separate is separating them with the space, but what's the other?
So actually, so this is cat x squared with a space and additional separators of nothing. So it's a little strange, but basically we're just putting spaces in between each of these things. Yeah?
Why does that in not have the percent signs around it?
Why does so this in is used when you run a for loop. So the percent in percent is a check to see if this value exists in this vector. Okay? Check to see if this value exists in the thing. This one is not a check. It's saying do this thing for every value that's in this vector.
Okay.
So this in is paired with the for, and it's for basically some name that we made up in this thing. Okay.
What does the cat do again?
Cat just combines a bunch of text together, concatenates text. So, you know, if you take pine and apple, puts them together, pineapple, you know, so it just sticks them, it just glues letters together.
Yeah.
Yeah.
Not that.
Huh? Is a separator. So okay, cat does a couple weird things, and so I think the default separator is something else. So I'm saying paste, you know, whatever you get when you get x squared, paste it with a space, and don't use any other separators. All right, and then we get basically this.
If you didn't have that set.
Don't worry about this, okay? Okay. Sometimes cat is a useful thing. Don't worry about it, okay? Here I have a list, okay? And a list, you know, you could have different stuff. So here I have a list 1, 2, 3. The second item in the list is A, B, C, D, E, F, G. The third item in the list is true, false. And when you iterate over something you can iterate over basically anything. You can iterate over a list. You can iterate over a vector. Probably the most common thing you'll iterate over is going to be something like 1:10, and you're going to do this for x equals 1, x equals 2, x equals 3. But you can iterate over something like this. And here I'm saying, okay, go through each item in the list, and when you do, print out the length of whatever that item is. So it goes to the first item in the list. What is its length? There's 3 things in there, so it prints out 3. Go to the second item in the list. What is its length? There's 7 things in that list, so it prints out 7, or 7 things in that item, I should say. Go to the third object in the list. What is its length? There's 2 things, so it prints out at 2. Okay? So you can iterate through any kind of vector. Most frequently, your vectors will probably be 1:10, 1:100, 1:5000, something like that. But it doesn't necessarily have to be. So here's another vector where I just have the state names: Alabama, Alaska, Arizona, Arkansas, California. I don't know, did you guys learn how to, all the 50 states in alphabetical order and whatnot? Okay, so anyway, so we're just gonna say, okay, here's a vector, and we're gonna go for each item in the vector. And so I'm gonna say for each, and again, just an arbitrary name, but I said take the state in that vector, state names 1 through 5, and here's cat again, okay? And cat by default will take whatever it is, and then I'm saying tack on the word has, and then figure out how many characters are in that item, that state, and then tack on some additional text. Yeah, question.
You just made up state, like it could be X. Like
Yeah, it could be X. For X and state name, yeah. A lot of times it's useful to pick a variable name that gives you an idea of what you're reading, but R is not like, it's not an AI or anything like that. It has no contextual awareness, right? I could have said for country and state name, and it would have done it. It would have been confusing for anybody reading this because it's like, what? But yeah. I could have just done X or anything else, okay? I think using the word state makes sense, but that's what we have, okay? And then it goes through, and it does it for Alabama, and it says Alabama has, how many characters are in Alabama? 7, and then it tacks on letters in its name, okay? And there you go. So California has 10 letters. What's the state with the longest name?
Mississippi, maybe.
Rhode Island? I don't know.
Oh,
Tennessee? I don't know. Now I'm curious.
let's get to the bottom of this.
What is library data sets?
Rhode Island, I think, is the longest.
Okay, so
According to Google.
state name. All right, so we'll do N character. Oh, West Virginia, South Carolina.
Google says Rhode Island.
Okay, so we'll do we'll say max 14, which state name is equal to, I could do max of this or just which one's equal to 14. Whoops. Which state name is equal to, oh, which state name, okay, 33 and 40, all right. state name of 33 and 40. Got this square brackets. North Carolina and South Carolina. Those have 14. Well, how many letters are in Rhode Island?
Does that count the space?
Yeah,
though?
that's what that.
And should the space count?
The space
I
is
don't
right,
know.
right? So,
I guess.
There's only 12.
Oh. Google beat live.
South
they
Carolina.
don't count as space.
Yeah, so North Carolina and South Carolina have 14 characters in their name. They have the longest state names. Okay.
That's crazy.
Okay, well now that has been settled. Okay. Or maybe they call North Carolina N Carolina? No, it's North, North space Carolina.
Google's discrimination.
Okay. Sometimes you want to store the results as you go through a vector. And so one thing I recommend doing is creating an empty vector. So here I'm doing like 10 to the 7, that's like 100 million things, okay? Or 10 million things. And I'm saying calculate the square value of each of these things. And here I'm creating an empty vector where we're going to store it. So I'm saying results, RES is for results, repeat missing values 100 million or 10 million times. And then for X in sequence along basically does 1, 2, 3, 4, 5, all the way up to the max value. So if you know exactly how long it is, like if you know it's 50, you can do for X in 1:50. But if you don't know how long your vector is, you can always just do sequence along, and it's going to start off at 1 and it's going to end exactly when it needs to end, and it's not going to go over or under. So sequence along is kind of like a handy little function that I recommend using, because sometimes later on you change your mind and you're like, oh, you know what, instead of 500 I want to do 600. And then if you forget to change your for loop from 1:500 to 1:600, then you might run into problems. But if you use sequence along, you just change it in one place. I want to go from 500 length to 600 length. Sequence along will go, oh, you've changed your length, and it adapts accordingly. So that's what this sequence along is. And so here it's going to sequence along this thing, and it's going to do that, and it takes less than a second on my computer to do that. Over here, I just started off with a vector that has just one value, and then I could do kind of the same thing for X in 1 to 10 million, okay? And so here I didn't do a sequence along. Here I just said, okay, go from 1 to 10 million. And this takes, about 5 times longer, or 4.5 times, I don't know, whatever. About 3 seconds. I mean, this is not a huge difference, but it does take more time. And that's because every time you do this, R goes, oh, I have to allocate more memory, right? So it started off, it says, oh, I need to store one value, and it allocates this much memory on your computer. And it says, oh, you got another value? Okay, all right, here's some more room. Oh, you had another child. Okay, here we're gonna we'll make some more room for this, right? And then you get to 100 million, and it's like, okay, are we still adding more stuff? Right? And so R has to kind of resize each of these things, okay? And then the worst one is sometimes people will take the existing thing and then like tack on a value and then save it back. So it's like take your current results, add this thing on, and then save it back in results. And this requires like copying everything. So it's like, okay, we started off with 1, and then we're gonna take 1 and we're gonna add on 4, and then we're gonna take 1 and 4, and then we're gonna copy that and add on 9, and so on and so forth. And this takes a really long time. And so even though I only went to 100,000, that took like 13 seconds, and you could just imagine if I had to do this for 10 million, it would break my computer here, okay? I'm running out of time, but while loops use a condition, and it's gonna, so a for loop says, do it for every single thing in this kind of vector. So if you have 10 things in your vector, it's gonna do it 10 times. If you have 50 things in your vector, it's going to do it 50 times. That's what a for loop is. You know, you want to do it for every single thing. Like if you have a list and you want to do the same thing for every single item in your list, a for loop is great for that, okay? Other times, you don't know exactly how many times you need to run something, right? So sometimes you have a process and you just say, keep repeating it until you're finished, okay? Well, how many is that? When am I done? Am I done after 5? Am I done after 10? Am I done after 20? We don't know. So if you say, keep doing something until you're finished, you're gonna use something like a while loop, okay? Basically, while you are not done, do this, okay? So basically, this statement is the condition, and so while this thing is true, do this, and you're gonna have something that's gonna finally switch to basically off. So while it's on, keep running until you reach a condition where it turns off. And so here we're gonna say, while I is less than or equal to 10, store I squared into results, okay? And then count up. So we start off with I equal to 1, and then we're gonna store I squared into position I. So for the first iteration, we start with 1 and we do 1 squared, and we're going to store it into position 1. And then we increment I. We go I plus 1. So now I is 2. And then we do 2 squared and we store it into position 2. And then we increment. I becomes 3. I becomes 4. And then finally we get to I equals 10. And we say, while I is 10 less than or equal to 10? Yes, that's true. So it says 10 squared gets stored into position 10, and then I becomes 11. And then now that it's 11, it goes back to the while loop, and it says, well, is 11 less than or equal to 10? That's a false, right? 11 is no longer less than or equal to 10, so it quits, all right? And so the results are 1 through 100. And what is the value of I? I is equal to 11 at the end of that loop. Okay, I've run out of time. I only give you one answer so far? Okay, last two are D and A, dog and apple. Dog and apple for question 2 and question 3. D and A, dog and apple. Okay, well, I guess we can cover a little bit more of this on Friday, and then, well, we have to talk about ethics and stuff. You're like, whoa, why ethics? But there's actually a lot of important things to consider when looking at data. So, so we'll talk about that on Friday, maybe even some on the following week. Make sure you're meeting up with your groups, and make sure you're looking for data, and go through the rubric to kind of make sure you're meeting what I'm expecting.
How many chapters are we going?